Hello everyone, we have section review of section 2. Which of the following are examples of specular reflection and diffuse reflection? Reflection of light from the surface of a lake on a calm day. This is specular reflection because a lake is a smooth and shiny surface. Reflection of light from a plastic trash bag. A trash bag is not a smooth and shiny surface, so it's diffuse reflection. C, reflection of light from the lenses of eyeglasses. Eyeglasses are smooth and shiny surfaces, so this is a specular reflection. D, reflection of light from a carpet. A carpet is a rough and not a shiny surface, so this is diffuse reflection. We have question 2. Question 2, it says what? It basically says that you have a giant clock and someone standing at 12 o'clock shines a beam of light toward you, and you want to use the mirror, a plane mirror of course, to reflect the beam toward an observer standing at number 5, okay, at 5 o'clock. What should be the angle of incidence to achieve this, and what should be the angle of reflection? Look at this, guys. You have someone here, okay, they are shining, number 12 here, someone is here. From here a light beam is coming, okay, someone is here. And a light beam is coming from number 12. So a light beam is coming from number 12, and you are standing here in the middle. You are standing at the center of the clock. Look at this. This is the beam that comes from the person. So what should be the angle so that you can reflect this ray to 5 o'clock? So you want to reflect the ray to 5 o'clock. Let's do this first. How many numbers do we have? Of course, we have 12 numbers, 1 to 12. Then if you want to make a full circle around the clock, how many angles do we have? What's the number of the angles? It's going to be 360. Okay, so each number gets how many angles? This one is going to get what? This one, this one, this one, and this one. Let's calculate it. So this is going to be what? We have 360 degrees because we are making a full circle divided by 12. So each number is going to have an angle of 30. So number 1 is going to have an angle of 30. Number 2 is going to also have an angle of 30. Why did we do this? Because we need to know the angle of each of the numbers. Okay, now that we know the angle of each number, it's going to be pretty easy. We are going to reflect this ray back to number 5. Okay, we're going to reflect this number to 5. So 1 to 5. Each number had an angle of 30, and I have 5 numbers. So 30 multiplied by 5 is going to be 150. So the angle from 12 until 5 is equal to 150. But I need what? I need the angle of incidence and angle of reflection. So we're going to just divide this by 2. So 150 divided by 2 is going to be equal to 75. So angle of incidence, why did I divide this by 2? Because remember that the angle of incidence and angle of reflection are the same. So basically dividing them by 2, you're going to get equal angle of incidence and angle of reflection. So if we try to do this, this is going to be what? This is going to be 75 degree, and this side also is going to be 75 degree. So my angle, the angle of incidence and the angle of reflection should be 75, so that the light beam that comes from number 12 is reflected to number 5. We have this question. Some department stores, so windows are slanted inward at the bottom. This is to decrease the glare from brightly illuminated buildings across the street, which would make it difficult for shoppers to see the display inside and near the bottom of the window. Sketch a light ray reflecting from such a window to show how this technique works. So this is done. The windows are slanted or inclined a little bit so that as you see here, so that if it's not slanted like this, okay, it's like straight, it's going to hit directly the eyes of the customers. But if it's like this, a little bit inclined and slanted, it's going to what? It's not going to hit the eyes of the customers. That is the reason. We have question 4. The photograph below shows the multiple images that were created by multiple reflections between two flat mirrors. What conclusions can you make about the relative orientation of the mirrors? So the mirrors are placed like this. These are the two mirrors. The angle between them is 0 and they are parallel. If two mirrors are placed parallel to each other, they're going to have multiple or infinite number of images. If one wall of a room consists of a large flat mirror, how much larger will the room appear to be? Explain your answer. So basically, if there is a mirror inside a room, it's going to reflect the space behind you, creating the illusion of a larger space. Let's say the space behind you is 2 meters. Inside the mirror is also going to be 2 meters, okay? So it's going to appear to be 4 times or 2 times larger than the normal size, than the actual size of the room. But in reality, it is just the same size. It never changes. But it's just an illusion created by the flat mirror in the room. Does a flat mirror appear to reverse the person looking to a mirror left to right, but not up to down? Yes, a flat mirror, just reverses the person's look from left to right, not upside down. This happens because a flat mirror reflects light symmetrically. This is section review. See you in the next video.